You willing to do that?
Of course.
Thank you. Let me see, hold on.
Did it start recording? Okay, yeah.
Yeah,
Okay.
it's catching some really exciting action right now.
Yeah, it is.
I think whoever asked me that question just now, I think that's the only copy I have up there. I think I've given them all away. Yeah, I got copies of every other thing I've handed out in class.
Isn't it that paper right there?
No, this is the latest handout. Oh, here we go. Who needs a copy of that? Okay.
I'm sorry, which one? Oh, sure.
Okay.
I'd like one.
Okay.
I know. Thank you. Okay.
Yeah, thanks. All right. So, I mean, this is really just a nice visual for what I need to talk about for getting into section 6.7. And again, 6.6 is the extra credit one. So even if you're online, I made it not worth any points. If you do it, I'll go in and physically see what you did and just tack on some extra points to your homework grade if you're doing online work. It's up there. So, I mean, this looks normal, right? Now, if I drew a normal curve on top of that, what's the fundamental difference between the normal curve and this dude? I mean, we all know what we mean when we say that looks roughly normal. But do you guys know why it's not exactly right? They're very different things.
That one's been moved.
How do you mean?
Like, it's like,
It's a sad movie.
it's been shifted.
I've been moved.
It's been shifted, hasn't it?
That doesn't matter. Every one of them has been shifted to wherever its mean is. It's not a big deal. All right. So the main difference between a normal curve, a truly normal curve, and a binomial distribution is that the binomial is discrete data. Right? What can you have for a binomial? If I flip a coin 14 times, can I get 5.87629 heads?
No.
No, that would be excessively weird. Right? I really want you guys with me on this. Okay. So, if I want to use z-scores, which come from and describe a continuous distribution, if I want to use them to talk about these, which are 9, 10, 11, I need something to correct for the fact that this is not continuous. So what we do is, and so the real reason, the real problem is 6 isn't really just 6. The way I kind of correct for it is what we kind of did here, what I did when I made this. 6 isn't really 6. If I want to know the probability of at most 6 heads, 6 heads, 6 people, that's the elevator thing. If I want to know the probability of at most 6 heads, I want to know from 0 up to 6. If I did from 0 to 6, why does that not work? Would that capture the whole 6 bar?
Yeah.
No.
Because what does the 6 bar go up to?
7.
It doesn't go up to 7, it goes up to
To
6.5, right? So the continuity correction, actual name, right? So it corrects for the fact that this is not continuous. So if I want to make z-scores out of these things, I can't make a z-score out of 6. I have to make a z-score, in this example, I have to make a z-score out of 6.5. So let's try that out, and then we'll focus just on how the hell that correction works. You guys get that?
Can you say
If
that
I
one more time?
only try to go add up from 0 up to 6 exactly, then I have to take half this bar. So I want to go from 0 up to 6.5. Maybe. All right, maybe. So somebody remind me, what did we get? Who's got the one that's filled in? The mean, obviously, for this one was, this was flipping a coin 14 times. So I expect to get 7 heads. What was the standard deviation we got?
1.871.
1.871. So those of you just got a handout today, you don't see that work on there, but It's the same old formulas we use, square root of NPQ and all that kind of stuff. If I want to know the probability of at most 6 hens, when I graph this, I have 7 here, here's 6. And 6 is really this bar here, right? So the very first thing I really need to do, and it's the very last thing we talked about last time, I think, if I remember correctly, is to check to see if this is normal enough. So I was trying to make this huge deal out of something being normal enough. Normal enough for what? For police work? For normal enough for what? Yeah, normal enough to use what? What do we have? What do we need a normal curve to be able to use? That we just recently started using. The chart, yeah, the chart. Period. I can't convert z-scores into precise areas unless I know it's normal. Then I got the whole freaking chart with all those numbers all over the damn thing, right? So what do I check in an NPQ problem? What do I check to see if it's normal enough? Who remembers or who took good notes and can see what I said? Beautiful. If NP is greater than 5 and NQ is greater than 5. And I think this book, I think I looked, depending on the book you use, this book says, I want to be the same as the book. This book, yeah, so this book says at least 5. Yes.
Could you go over what the continuity correction is again?
Yes, we just started getting into it. Don't worry.
Okay.
That's what this whole discussion is going to really be centered around. Yeah.
And that's another part of the central limit theorem?
No, this is actually a separate idea. It kind of looks like the central limit theorem because the central limit theorem says if you take samples of size greater than 30, then your sampling distribution will be normal enough, right? So that's for a continuous variable, right? That would be true for any continuous variable. For a binomial or a discrete thing, so for a binomial specifically for NPQ problems, that's got to be true. So this is the binomial check to see if it's normal enough.
What does normal enough mean again?
So normal enough means, that enough means normal enough to use the z-score chart to look up areas. Cool. So let's do this one problem, compare it to what we get if we just add the probabilities up, and then I'll give you a little motivation as to why the hell this would be something we'd want to do. So we'll just do it backwards. We'll do it first, and then I'll tell you why we want to be able to do it. All right? Just because. Normally it's done the other way. So screw the normal way. So if I want to know less than, at most 6, so that really means up to 6, do I want to include this bar or not?
Yes.
Yes. So I really want to go up to 6.5. Now let me just stop right there. Does that by itself make sense? Visually, this is really what's going on. And to be honest, if I didn't make each bar that wide, that's really why this thing is not continuous. This thing is not continuous because there's big gaps in between, isn't there? 6 and then 7. Well, if I pretend like 6 is 5.5 to 6.5, well, what's 7? 7 is really
6.5.
Is there any gap? No, because 6 goes up to 6.5, 7 starts at 6.5. There's no gaps. I'm pretending that it's continuous. Now, if I use the word pretend, it makes this whole thing sound a little less stable, a little less rigorous. But I want you to realize it's a bad word for me to use, but what I'm really doing, I'm adjusting this so that it becomes more continuous. And the answer I get won't be exactly right, but it's an approximation. In fact, that's in the title of what the hell we're doing. So what we're really doing here is called you'll love this, normal approximation to the binomial distribution. Right. Sounds like politician speech somehow. So normal approximation. So I call this the NAB for short, right? So when you see me say use the NAB, and I will do that because I'm a nice guy nowadays. I didn't used to do that when I started teaching stats, but then I realized I pretty much had to. When I say use the NAB, it means you want to do this kind of thing. It means that you have to use a continuity correction. So normally I would just make a z-score out of 6 and look up the area on the chart, right? Because I would have a continuous variable, or I have something that was continuous. When I have an NPQ problem, notice how I keep saying that, NPQ problem. That tells you it's binomial if you have an NPQ. If I have an NPQ problem, I have bars, actually. Z-score chart's not good for little bars. It's only good for a true normal curve. So I have to do this adjustment. Okay, so let's see. Let's do this both ways, just because. So what do I mean by both ways? Let's do it using 6, and then we'll use it using 6.5, and we'll see which one's closer to the real probability. Okay. So let's make a z-score out of 6. So here's the mean, here's the standard deviation. It's normal enough, right? What's NP? N here is what?
14.
14, because I'm flipping this thing 14 times, and P, of course, is 0.5, and that comes out to be 7. Is that good? Check, yes. It's greater than 5, or at least 5, check. What's NQ? 14 times 0.5, right? It's 50-50. That's 7, that's greater than 5, check. So it's normal enough. I'm allowed to do this. I'm allowed to use z-scores for this bar problem. Z-scores normally aren't good for that. Right? So, somebody help me out. How do I make a z-score out of? So I'm going to do the first way without continuity correction. That's what I mean when I say CC. Right? Too many letters in continuity correction. So I'm going to call it CC. So without the continuity correction. So this is going to be wrong. I want to tell you up front. So what's the z-score for 6? How do I make 6 into a z-score? No. How do I make 6 into a z-score? I'm not going to use the continuity correction. I'm going to do this incorrectly. I want to show you that it's nowhere near the right answer. So it's my score minus the mean. So again, I really want to emphasize this. This is wrong, what we're doing. So why am I doing it? Just to show you that it is wrong, and you shouldn't do it. 6 minus 7 over 1.871, right? The z-score formula really never changes. Our data minus the middle divided by the standard deviation. And what do you guys get for that? Somebody help me out.
-0.53.
Negative 0.53. Confirmation. Yes, okay, all right. So if you look up negative 0.53 on the z-score chart, what do we get?
2877. 2877.
Say one more time, sorry.
2877.
2877?
Yeah.
So that's what this way tells me. Now let's do this the correct way. This way is saying, oh, I didn't realize it wasn't normal. I thought it was. I didn't realize it wasn't continuous. So that's a mistake. Is this continuous data? Hell no. You can't have 6.83 heads. 6, 7, 8. So let's do it the right way. Sounds smart. Take this out. So the right way would be with the continuity correction. So my question is less than 6, but when I use the continuity correction, it becomes less than 6.5, like we were talking about earlier. So I like the pained look on some of your faces, like, you just said we're going to do 6.5. No. So I want to get that number to show you it's nowhere near the right number. And the number we're going to get from this one, it's going to be really pretty close. So this becomes less than 6.5. So at most 6 would actually be that. It's my bet. That becomes very important now as far as which side of the bar I go to. So we went to 6.5 because we want to include it. So if I go here and I shade down from here, do I include the bar? I don't? Do I include the bar? If I started here and went down, if I started at 5.5, do I include the bar? No. But if I start at the back wall and go this way, I do include the bar. And I want to include 6, don't I? Because this is at most 6. That would include 6. If I said less than 6, where would I have wanted to start? 5.5, because I wouldn't want to include 6, would I? And what represents 6? This bar. Right? So you just got to start on one side of the bar or the other. We'll focus on continuity correction in just a second. But I think we all were cool with 6.5. We're realizing now that there's a little more to this. So now, if you make a z-score out of 6.5, what would that look like?
6.5.
Same thing here, right? Just with the 6.5. What was it? 871. Negative 0.27. Verification. Yes. Okay, good. Rounding correctly?
Mm-hmm.
Good. All right. So just always round when you get those z-scores. So when you look that up in the chart, what do you get?
0.4129.
So then you get 0.4129. Is that cool? Being very trusting. It sounds about right to me. But I don't have the z-score chart memorized. And I don't plan on it. Right? I'll memorize as much of that as I did of pi, which is not much. Now, what's the exact right answer? Because this right now doesn't make a lot of sense. And if I was in this classroom, I'd say, why the hell are we doing this shit? I know all the probabilities here. I got a little table here. What is the probability I have at most 6? I got a table of all the probabilities. So what is the probability of at most 6? Do you want to just add up from 0 to 6? So what do you get when you add those up?
0.395.
0.395? And what's that closer to? 2877 or 4129? Yes, sir.
It's 0.3936.
That's better. Thank you. Right when you said that, I'm like, this should not be that far off. So if you look up negative 0.27, double check that. Negative 0.27.
0.3936.
Normally crowdsourcing works for me, but not enough of you guys double checked it. Negative 0.27, 0.3936. Now it's even more, not as appropriately impressive, hopefully. So if we did this, that is a mistake, because fundamentally our problem is discrete. And the z-score, the normal distribution, is continuous. So on one level you're like, well, why the hell would I even think they mesh? Well, I can pretend to be continuous if I use 6 isn't 6, 6 is 5.5 to 6.5. And just depending on if I want to include it or not, I do one side or the other. It's an approximation, though. It's never going to be perfect. But the real answer, you said, was 0.395. That's the real answer. If I just use the binomial, I get 0.395. If I use the NAB, which is the continuity correction, I get 0.3936. And if I don't use the NAB, if I just use a z-score directly, without any correction, I just get 0.2877. All right, so I think we can throw that out. That sucks. All right. And this is really damn close. I'm only off by 0.0014. That's really good for an approximation. Okay, now, of course, none of you quite have this yet. This is one problem. Let's do several more. So first I want to give you a little motivation as to why the hell you want to be able to do this. And to be honest, some of my colleagues don't even teach this anymore. So some of you guys are like, man, why didn't I sign up for that? But this is important because a lot of what we do in chapter 7 and 8 actually are built on ideas you learn here. So to me, it's silly to throw this out just because your calculator can do this. You got the little binomial PDF and CDF thing. Remember we talked about that? Yep. So you can do that no matter what. Ooh, what-de-do. Pushing buttons doesn't teach you anything. So let me give you a situation where you would not want to do it using the formula. So first off, a little review. What formula am I talking about? Let's do a problem that we could do. Let's say, what you got? 81% of first one students have to take math 160. That's probably a little high. A lot of people do. So if we pick 38 students. What's the probability that exactly 27 will need to take stats? And what situation is that? You. I know what you mean. Can you identify an N? Can you identify a P? And if you can identify a P, then you must get a Q, right? You could see an NPQ, that's what I call an NPQ problem, that's a binomial problem. Now this one I don't need any help with. I mean, this is, I just need one formula use and I'm done. So I'm not going to do any z-score weirdness for this problem. This is just a review. So what would the formula look like?
38, choose 27.
Yeah, I got 38 people. Choose 27.
Times 0.81 to the 27.
Good. So I want 27 successes, which means 11. And what's the failure probability? 19%. Right, because these two have to add up to be 100. So most of you guys did pretty well with that question on the quiz. Some of you guys look like you'd never seen it before, so this probably means you haven't done the homework yet. And then you just got to plug in the calculator. Maybe I should do it too. All right. Let's compare them. What do you guys do?
0.1473.
Good. 474. Cool. All right, so that's a little review. That's what I mean when I say the probability formula for binomial. Now, what if it was this instead? Same kind of setup, but now I'm going to pick, for number 2, I'll say I pick 7,000 gross month students. Right? What's the probability that, what you want to say, Jeff? I don't know. Let's see. What's probably that more than 5,612 have to take Math 160? So I go out and randomly select 7,000 gross month students. It's probably that at least that many have to take. So maybe I want to see how many sections to make. You guys kind of follow? So if more than that needed, I have to add another section or something than what's currently scheduled. That's kind of like a background as to why I would even be interested in this question in the first place. Now, can you imagine your professor, who's currently standing in front of you, does not let you use binomial PDF or CDF to actually do the problem? And to be really super honest, binomial CDF in that will freak the hell out on some of these problems. It'll be an overflow error. So sometimes your technology is not going to be able to do this. So in those cases, you definitely have to use a z-score, a normal distribution to do it. Because then you just look at the chart, and the chart never has error. The chart's just sitting there looking at you. All right, cool, you're not technology. You won't say error after it. It's just a piece of paper. So in order to do this problem by hand, I'd have to do this formula about how many times? Because what's greater than 5,612? 5,613. 5,614. So I have to do this formula for every single value up to 7,000. Do you want it? I'll leave that as an option. If you want to do that, I'll leave that as an option for you, right? I don't care how much of a smartass you are. I don't think any of you are going to take me up on that. I'm waiting for the day that happens. Come in with the papers like that. No, I'll take your word for it. So I have to use the NAB. So this would be exactly the situation that I have on a test. And I'd say use the NAB to find this probability. And this is your clue. This is me trying to give you a little clue. Oh yeah, that's where I got to draw the little box and pick the correct side. So in this case, if I want more than 5,612, so somebody help me out. Let's do this problem out. What's the average in this problem? What's n now? 7,000. And p, of course, is still 0.81. So q is the 0.19. So what's the mean? All right, so now you see why I picked that number. I wanted it to not be a problem, right? So I knew I wanted something close to this. 5,670, that's the average. What's the standard deviation? Square root of n, p, q.
$32.822.
32.822. Is anybody else doing that?
Working on it.
And you got the same thing?
38 or 32.82
Two. Okay.
or 2.
Gotcha. So far, so good. You can always find the mean and the standard deviation for a binomial and NPQ situation easily. You got to love those formulas compared to every other formula we've done so far. That kicks so much ass. It's a one-liner. Good Lord. Every other formula we had was like these huge tables and shit. No. This is beautiful. So now and what do I check to see if it's normal enough? And what's beautiful about the check? NP I've already got. What's NP?
5,670.
It's the mean, 5,670. Is that bigger than 5? Yeah. Now here's the shortcut for NQ. NP is the average number of successes. So NQ must be the average number of failures. So if I got 7,000 total, and I got this many successes I expect, how many should I expect for failures? The rest. 7,000 minus this. If you don't trust me, do n times q. Bless
Bless
you.
you.
N times q would be 7,000 times 0.19. And 1330 is this subtracted from 7,000. Right? Good. And 1330 is just a little bit bigger than 5. Cool. Stop there. So what did that check just do for me? What does that mean?
It's normal.
Normal enough. Good. I love it. To use the chart to get up probabilities. I like it. Because that method is a lot better than, doing this formula 2,000 some odd times. Okay. Maybe. Let me make a little room here. So let's graph our situation here. So in this case, I want the probability, what was it, greater than 5612, right?
Yep.
So what do I put on my picture now? It's normal enough I can draw this picture. So what goes right in the middle? The mean, good. So 5670. 5612 would be down here somewhere, kid. And you draw a little box. That's what, when I say use the nav, that's what I'm trying to tell you. You've got to do this. Because when you draw this, that's nice, but that's not really the situation. You have a bunch of little boxes, is the real situation. Now, if I want greater than 5,612, which way am I going to shade? Good, I'm going to shade up. Do I want to include the box that represents 5612?
No,
Why not?
because it's not equal to.
This is greater. It's not allowed to equal it, right? So do I want to start back here and shade up, or start up here and shade up? I want to start up here and shade up. You guys, that's it. That's it. Don't memorize shit. Don't. Just draw the picture. Think about it for like 3 seconds. If I start here and shade up, I include it. I don't want to include it. So I'm going to start it here and shade up. So where am I going to start? 5612.5. That's the continuity correction. You make a z-score out of that. Now the effect won't be as big here because these numbers are already pretty big, so half a step is not that big of a deal. But we saw the effect could be pretty big if I don't make that correction. So so not to confuse two things, but I want to show you what's going on. We have the standard z-score problem, right? 6.2 and 6.3. Standard z-score problem. You got to get that bad boy down. Then we talked about central limit theorem. And what's the big thing about central limit theorem as far as you guys working your problem out? What's the one thing you have to change? When I take a sample and I ask about the sample mean, what has to change?
Standard deviation.
Standard deviation, right? The thing gets smaller, comes to the middle. Does that ring a bell?
Yes.
So we're tweaking things now. And I told you the first day, that's what stats is all about. You have to know what the situation you're in and what happens to the formulas you have to use. We're in the middle of that stuff right now. So if I have a continuous curve and I take a sample size 48, I've got to change my standard deviation, and then I do everything's the same. Here, if I have a NPQ binomial situation and I want to use z-scores, I get my mean and standard deviation, and then I make this one tweak, and then everything else is the same. Make a z-score out of this, look it up on the chart, make sure you get the right area, right? All the stuff after you make the tweak, everything's the same after that. So how do I make a z-score out of this?
56125 minus 5670.
Good. So my data point minus the mean. Yeah, what was it? Where'd it go? 32.822. Negative 1.75. Is that cool? Some of you guys are nodding your head. I'm not sure if you put that in calculator. Sounds good as a number. And if you look that up in the chart, will that be the answer?
No.
Of course not, because we want more. We shaded up. So if you look that up in the chart, you'll get this much. So what do you get when you look up negative 1.75?
0.0401.
0.0401. So the real answer, 1 minus that, 0.9599. And again, for anybody that's still doing the shortcut, remember the shortcut, if you just looked up positive 175, you get that answer there. Right? But if you don't understand it, never use it. It's not really worth it. Very minimal savings in time. Some of you guys are like, what are you talking about? Good, just don't worry about it. Do that.
So you can also find it just by changing it to a positive.
Yeah, it's the shortcut, because the symmetry.
Okay.
Well, the area of this would be the same thing as the area below positive 175. And that's why it's a little shortcut, because the chart's built to tell you areas below. Okay, maybe. So let's focus on the one step, the continuity correction by itself. So I want to give you a couple of lightning round questions. Right? It's not going to be the whole process. I just want to know, what would the continuity correction become? So what do you got with the one here? More than you ever wanted? Okay. So, here's some situation. I think green's a good choice. You guys see that? So I want to know, tell me, ooh, that's evil. Sorry. What am I thinking about? Tell me what that would become after the continuity correction. Things like that freak me out with Ebola out there. Little containers just suddenly popping up out of nowhere. I don't think stats teach you to be the main target for terrorists. isn't mine there. All right, so what would this become? So if you draw a little picture for yourself, you don't have to draw the whole curve. You just put a little box on 11. You would shade which way?
To the right.
You'd shade the way that's pointing. If you want to do that one, right? I don't know if you remember that from algebra. That's how you want a number line. That's where you shade. So you would shade down if you want to. You want to include 11 or no?
Yes.
So do I want to do from down or from up?
Love.
Yes. So that include the bar. So the continuity correction would say this is the same thing as probably x less than or equal to 11.5 to gas. And then you make a z-score out of that, blah, blah, blah. This is assuming that the check worked. It's normal enough. So that's why I'm even doing anything. Cool? Maybe. So what about this guy? Same thing. Draw a little box on 19. Now you're going to shade up. And again, you want to include 19.
Yep.
So you don't want to start there, you want to start there. So this will become probably x greater than or equal to 18.5. You make a z-score out of that, look it up. So I've had people that try to memorize something here. I don't know why you would do that when it takes that long just to look at it. I don't have enough space left in my brain for that. So what about here? I got 1917, draw a little box. I want greater than this. So do I want to include 1917?
No.
No, that was a bad year. I don't know if you guys. That's some things all started. This is not history class, so we'll stick with math. So I don't want to include the bar, so I want to start here. So this would become
0.5, 1917.
1917.5, the upper side I want to start at. Do you guys see that? I want you to realize. I don't know if you remember the other day, but when we were going through all the process of why the standard deviation changes and why does it make sense, and you pick these numbers out of a hat, and I had all this stuff to look at, and then it all boiled down to don't make a z-score until you change your standard deviation. Ooh, right? So the actual nuts and bolts of what happened to you work-wise was incredibly minimal. Same thing here. Don't make a z-score out of that. Make a z-score out of that. And then look it up in the chart and get the area and go forward. The effect is not huge. The concept is weird behind it a little bit, but the effect on your work is not big at all. Okay, maybe. So let me give you a complete problem of your own to do. So here's the situation. What you got, Jeff? Making up more stuff. 28% of Americans watch the O Network. Is that even still on? I don't know.
The Oxygen? Oxygen? Is that
No,
right?
I think Game of Thrones would be the other side, wouldn't it?
Probably.
How many of you guys watch Game of Thrones? Anybody? It's insane. Sorry. All right. How many of you guys watch The Walking Dead? Boom. All right.
It's a great episode.
Good. No, don't say word. I'm like a season and a half behind. I'm like catching up as I can. I know the new season just started. And like over half of you are like, stop talking about this damn show. I don't care about it. So 20% of Americans watch
Breaking Bad.
watch network news. That's probably true. Any of you guys watch the news on TV?
Yeah.
No.
I
Some of you guys?
have to.
Yeah. If I'm on somewhere in the hotel, I'll turn CNN on in the morning just to have background noise. That's where they get the ratings. Nothing against them. So 20% of Americans watch network news. If we randomly select, how many, Jeff? 9,560 Americans.
Wow.
Yeah, we did. What's the probability that, let's see, something that won't freak this out too much. At most, just pick something, Jeff. 2,850 Americans watch it. all you need to go. So don't forget, the very first thing you should do is, get the mean and standard deviation and check NP and NQ. Okay. We can work on this together if you want to. It's not a quiz or anything. Ooh, I like it. Okay, good. Yep. Yep. That one right there. I have a whole bag of them. Virtual one, if you want to use that.
Yeah, so it would be.
But wait,
Yes. Yes.
five, right?
Yeah.
It's always 5.5. It's the beauty of this.
I mean,
It's always whole numbers because we're talking about people here, right? So it's always going to be just a half up or a half down. Always.
So if it's at most, you would stop at.
So now your question is where
which side?
you just say which way you're going to shade, and then you start drawing little arrows and say, do I want to include it or not? Yeah, so at most,
It's
up to and including. Good. So you do have to understand what some of these little English to math phrases, what they mean.
I don't know.
What these English phrases mean in Mathish.
What did you get for standard deviation? Did you get it already?
43.901.
Okay.
What's up?
We don't know what difference is going.
3.95.
That's cool, man.
I know this is not. Yeah, there's no way.
I got 3.38.
Did you all get the same mean and standard deviation?
I don't know.
Oh, well, that's a good place to start.
I just way that's
What did you get for your?
All right, let's make sure what the mean is.
For what?
for me. It's gonna be
Wait, we don't even need to know the z-score, do we?
No, we do.
Mm-hmm.
What do we need the z-score?
To find
So we
the
can get the probability.
Oh, yeah.
I like that. We don't even need the z-score. So that,
You can look at what is
Oh, that's right.
strain.
so
So it turns to 2850.5 minus.
Okay, I would do 0.285, so you would bring it to 29.
where we at? Sorry?
You've got, okay,
No. Where'd this come from?
okay.
So how we doing? Did you guys get these two numbers?
Yes.
The mean and the standard deviation there?
I got the standard
Yeah.
deviation.
Yes.
Yes.
So when you add like 0.5, you add just after that to be.
No. Not to either one of these. These don't change. These are set in stone for this problem. It's the data point. It's this guy that gets adjusted. Because I want the 2850 bar, so I've got to reference one side or the other of that bar. These guys are set. That's the middle. That's how spread out it is. You can't mess with those guys. What's up? You alright?
Oh no, I got it.
Okay. You just looked like somebody was tearing your...
the wrong number. I did 96.50 instead of 95.
Oh, okay.
So I
No.
got that number once I calculated all of that. So then what do I do with that? Is that...
Wait, so that's the calculator error.
Yeah, I probably put it
Yeah,
in there.
then watch this one. So that what this would do is it would divide these and then subtract that from this.
Oh, okay.
So you have to tell this poor little calculator dude, he doesn't have eyeballs, so he can't see this big bar in the middle. So you have to tell it what the top is. So you have to put, so that's the top. Yeah.
Oh,
And that's
okay.
still
That makes
something weird. So is that your standard deviation? Where's your standard deviation? There's your standard deviation, not this.
Oh, what?
So watch this. Hit second, enter.
that's the
I just changed that to what it's supposed to be.
Do I press clear?
Right, you just go back and type over it.
good job. Whenever.
And then just delete. If you hit clear, it'll clear the whole line away.
Yeah, that's what I always do. Yay. Okay.
Good, we'll talk about it.
So it is correct though.
Something like that.
Okay.
Good. I was trying to get somewhere around there, and it's awesome it did.
Does this look...
Negative, right?
I got a positive.
It's
Oh,
positive.
because...
It's positive because bigger minus smaller.
Yeah, it's positive. Yeah, it's positive. You're right.
So then would I get
Right,
the
just look
z-score?
at it.
Is that the z-score? Or I
Yes.
still have to get the z-score, right?
That's the z-score. That's the formula you just used,
Now
right?
you just
Oh, yeah.
probability.
Yeah.
Right.
All right.
Do you plug that into your...
So how are we doing? Are we to the point where we're trying to figure out what the hell the z-score is all about?
Yep.
What z-score do you guys get?
3.95.
3.95, somewhere around there.
Yeah.
So let's see, let me catch up to you guys. So a little picture dude goes on here. I got the mean is 2676.8. Of course, what do I have to do real quick? NP is 2676.8. That's good.
Yeah.
NQ is
Obviously bigger.
68 something. That's bigger than 5. Check. All right, good. So you have to do that check. And I'm cool with you just going, well, I like what you're saying, Antonio. The P is smaller than Q, so the NQ is going to be freaking bigger than that, and so it's bigger than 5. Screw it. Right? And I love it. That's perfect. You don't have to do that, all that work. You just say it's bigger than 5. So here's my mean in the middle. I'm interested in the 2850, so it will be a positive z-score. It's up here. and I want the probability at most. All right, so do I want to stop at the
No.
first wall or go through?
You want to go through the wall.
Yeah, I want to include it. So I'm going to shade from down here, I'm going to shade up, and I want to go through because I want to include this bar. So I have to go all the way up to 2850.5. That's the continuity correction. So then you make that into a z-score.
Yay!
All right, see a wide range of emotions. So you guys are like, what the hell? All right, so let's make this into a z-score. It'd be my data point minus the mean divided by standard deviation. I like it. And that's where you get the 3.9 something. Is it 5.7 or 5?
5.7.
So it's 3.96, even better. Now, what is your chart? Now, you look at your chart. What's it trying to tell you about that?
It's almost always.
Yeah, exactly. One thing I disagree with the chart. At 3.5, it's 0.9999, whatever, right? Once you start going past that, eventually it's going to be 0.99999, right? So it's not just always 0.9999 forever after that. That's what it seems like it's trying to say. That ain't right. But if you use a chart and you say 0.9999, I'm cool with that. That's what the chart says. Now, real quick, I want to show you. This one you can check on your calculator. How could you check this? Binomial CDF. It is a binomial probability problem. I checked it on the calculator. It won't overflow. So let's remember how to do this. If I go to second vars, right there, it'll get me into distributions. I see some normal stuff up top. That's interesting. Notice how I still haven't told you anything about that. And if you go down here, all right, I actually did. It's on your calculator Bible from way earlier. So binomial CDF. The inputs at once are always n, comma p, comma x. Doesn't need q. It's a calculator. It can figure out q once it knows p, right? So what's n?
9560.
Yeah, 9560. What's p?
0.28.
0.28. What's x?
2850.
2850. Yeah. So see, it's 0.99996. Because we went a little further than 3.5. The further up you go, the more area you're going to collect below you as you go up. Does that make sense? So if it would have said at least, or let's not change it, more than 2850, then I would have done 1 minus this, and I only got 0.0001, right? 0001. But if you get a z-score like 6, good Lord, say approximately 100%, or approximately 0 if it's the other way. Because at that point, you're at 999999999, and for any human, that's basically almost 100%. It's almost definitely going to happen. Okay? So that's a NAB problem. And if you look at the practice test, just to point this out, anybody not get their stuff back? Come in after I gave that? Anybody not get their stuff back? Oh, there, see?
Coach, you did say.
If you want to.
But not
Are
for
you
like.
talking about?
I was talking about yesterday, I'm kidding.
Yeah, just put that on her grade. All right.
Okay. Okay.
So on the practice test, which problem references the NAB. Yeah, the very last thing, very, very last thing. Makes sense, the very last thing we did. So I'm going to say exactly that. I'm going to say using the NAB, find the probability that whatever. So that is telling you you have to do this process. Cool. And what does NAB stand for?
Normal possible distribution. Or binomial distribution.
That's awesome. Oh, say, can you something? So yeah, it's the title of section 6-7. Just let you know. Let me think. What was the last? There was one other thing I can't remember.
So the test is next.
Next Wednesday?
Yes, next Wednesday. So on Monday we'll have review day. I'll have the answer key for the practice test. One last little thing to clear up something from the homework and from the quiz.
With the bonus question.
So if I asked you if something that is here is unusual, and I've given you nothing basically, right? It's a normal curve. What would your gut reaction be to if this, whatever this is, would that be unusual?
No, because it's like within one standard deviation.
Yeah, it's like barely step away, about a step away or something, right? If I ask you if something here is unusual,
Yeah, that's unusual.
yes. Now, it's not unusual because its probability is small. Because if that's the cutoff for unusual, something that's here could have a less than 5% chance of happening. This is unusual because the area of it and below is smaller than 5%. And that's kind of like in the homework, they keep trying to make that point. So if I took your exact height, your exact freaking height. I'm like doing crazy shit in labs and I'm doing these laser things and getting your exact height and saying there's a hair that goes up a micron. Let me add that on. How many people in the world are exactly the same height as you? Probably close to no one. So the probability of someone being your height is really small. So in that case, I go, holy shit, look how tall you are. You're weird. Right? Because nobody else, you guys try to see what I'm saying? So, but would you say I'm unusually short? Am I unusually short? Be honest with me.
No?
No, I'm about average. I wanted to play basketball, and then I stopped growing at 14. I was like, oh shit, that's it for me. But I'm not unusually anything. Short, tall, right? So it's not because my own personal height has a very small probability of occurring. Because not very many people are going to be exactly my height. But it's because where I am on the chart, I'm probably like there. There's a huge amount of people below me. So that's what you look for to tell if something is unusual. Or what we're going to eventually get into is it evidence that the mean isn't in the middle, it's actually somewhere else. So if you think, for example, that gas prices have dropped from where they say the middle is, and you go take a sample and you get it to be here. Well, that's certainly lower than what they say, but is that enough evidence that all gas stations' gas prices have gone lower? Well, that's what we got to figure out. That's going to be chapter 8. Is it far enough down so that this area below it is so small that you say, well, what's more likely is the average has dropped? You guys get that idea? Mm-hmm. So chapter 8 is what we're everything is kind of gearing up towards. I know we got chapter 7 in the middle. And chapter 7 is important in its own right. Confidence intervals. It was chapter 7 is all about. But chapter 8 is what everything's kind of gearing towards. Right, so that's in our near future. So those kind of problems in the homework when they ask you the difference between unlikely and unusual. So that's one thing I like about the new book that I just noticed. It does try to make a distinction between that. If a single thing's probability is less than 5%, that's unlikely. But it's not necessarily unusual, really. Right? To be unusual, in fact, where would unusual be on this picture? A normal curve, where exactly would unusual start? Yeah, -2 or 2. The 2 steps away in either direction. And that's not because anything out here has a 5% chance of happening. That's because the area of these two is what? What's the area out there? 5%. So it's not because any individual occurrence. It's because it's in an area of 5% occurrence. Right? So you can't say something is unusual because it itself has a low likelihood of happening. You say something is unusual because it's in an area where not much is around there. So that's why it would be unusual. Maybe. Okay, cool. All right. That's all I got for today. So that's completely fine with me.
Okay.
So I am so behind on grading. Thank you.
You're welcome.